Hello everyone, my name is Bilal Ahmed, and you are watching Basics for You. From the previous lecture, we started our new tutorial series on electronics. So, let's continue from where we left. If we talk about conduction of electricity, we have three types of materials, classified as conductors, insulators, and semiconductors. Conductors are the materials which have an ocean of free electrons, which helps in the conduction of electric current. Insulators are the materials which don't conduct electricity, as they don't have free electrons for the conduction. Now the semiconductors, which is the base for electronic engineering, are the materials whose conductivity lies in between conductors and insulators. Let's understand the conductivity of these materiali using the conduction band theory. The electron in any orbit of the atom is heaving and fixed energy associated with them, which keeps them in their fixed orbits. This is called as energy band. The electrons in the last orbit of the atom are called valence electrons, and the energy is called as valence band energy. When external energy is given to these valence electrons, they absorbs the energy and get excited and jumps to higher energy level. This higher energy level is called as the conduction band. The difference of energy between conduction band and valence band is called energy gap. Smaller the energy gap, larger will be the conductivity and vice versa. Now, have a look to these energy level diagrams. In case of conductors, valence band overlaps with conduction band and there exists zero energy differences. Thus, conductors have a large amount of conductivity. In case of insulators, the energy gaps that electron can't jump to conduction band, thus don't have any conductivity. But in case of semiconductors, the energy gap is very small, so a small amount of external energy excites the electrons to jumping into the conduction band and take parts in conduction of electricity. In case of silicon, this energy gap is 0.7 volts and for germanium it's 0.1 volt. Now semiconductors are also of two types. Intrinsic semiconductors. This is the purest form of the semiconductor. These are having a very negligible electrical conductivity. And the next class of semiconductors is called as extrinsic semiconductors. This is also called the impure form of the semiconductors. These are having a very large conductivity as compared to pure form. The extrinsic form of semiconductor is obtained by adding impurity to intrinsic semiconductor. The addition of impurity is called doping. Let's understand how this doping increases the conductivity. Before we start, please don't forget to support this channel, like, share and subscribe. Also hit the bell icon to get the notification for the next video. Let's begin. Here we have a purest form of silicon. You can see here that all the electrons of silicon atoms are bonded with other atoms of the silicon, and there is no free electron for the conduction. Thus, in this stage, this will behave as insulator. Now let's add some impurity to it. Before we add impurity, we must know about the type of impurity we are going to add. We have two types of external atoms that can be added as impurity. It can be trivalent impurity atom, for example, indium, aluminium, and boron, or it can be a pentavalent impurity atom, for example, arsenic, phosphorus and antimony. These external impurity atoms are called dopant. Now let's come back to our topic. We were going to add dopant to our intrinsic semiconductor made up of silicon. Let's add a trivalent dopant, aluminium, to this semiconductor. Here you can see that 3 electrons of aluminium have created a bond with 3 silicon atoms. And no electron is left for bonding in aluminium. But if you notice here, you will find that one silicon atom have one free electron which is not bonded to any other atom. This system is electrically neutral yet. This free electron will create a positive charge in the system near to aluminium atom. This charge is called as hole. Now before the creation of this positive hole in the system, the charge was balanced. But now we are heaving an imaginary positively charged hole in the system, which is technically an extra positive charge in the system. Now when we add a number of aluminium atoms in the system, we will have a large number of positively charged holes. When this impure doped semiconductor is connected to a supply, these holes takes parts in the conduction of electricity. The semiconductors, which have free holes for the conduction, are called p-type semiconductors. Now let's have a look, if we add a pentavalent dopant to this pure Si material. When we add a pentavalent atom to it, say, phosphorus, 4 electrons of phosphorus make bond with 4 silicon atoms, and there left 1 free electron of phosphorus, which takes parts in the conduction. This type of semiconductors, which have electron for the conduction, are called N-type semiconductors. Both holes and the electrons are called as charge carriers. This was the explanation about the construction of semiconductors. Next video will be based on how conduction takes place in semiconductor and also the construction of diode. Thank you for watching.